and then I replace with border radius 0. And then I do Command Enter, and it Git deploys. It pushes to the GitHub, and then sends a webhook, and then deploys to my server, and it's live in 5 seconds.
Oh, you often deploy it to production. You don't have like a testing ground?
No, so I'm like famous for this because I'm too lazy to set up like a staging server on my laptop every time. So nowadays I just deploy to production.
Yeah.
And I'm gonna get canceled for this, but it works very well for me because I have like PHP lint and JS lint, so it tells me when there's error, so I don't deploy. But literally I have like 37,000 Git commits in the last 12 months or something. So I make like small fixes and then Command Enter, and sends to GitHub. GitHub sends a webhook to my server. Web server pulls it, deploys to production, and it's there.
What's the latency of that from you pressing Command?
1 second. Can be 1 to 2 seconds.
So you just make a change, and then you're getting really good at like not making mistakes, basically.
Man, you're 100%. You're right. Like people are like, how can you do this? Well, you get good at not taking the server down, because you need to code more carefully. But it's idiotic in any big company, but for me it works because it makes me so fast. Like somebody will report a bug on Twitter, and I kind of do like a stopwatch, like how fast can I fix this bug, and then 2 minutes later, for example, it's fixed.
Yeah.
And it's fun because it's annoying for me to work with companies where you report a bug and it takes like 6 months.
Yeah.
It's like horrible. And it makes people really happy when you can really quickly solve their problems.
I'd like to quickly demonstrate why pushing to the main branch of a Git repository and doing straight production deploys without any test environments, without any reviews, especially for products and services and libraries that real developers and real users depend on, is a bad idea. Now, especially in today's day and age of nation-state actors and hackers and all kinds of different attacks that are going on, it's just a very bad idea. So what we're going to look at here is a Git repository, and we're going to kind of simulate attacking it and injecting a malicious commit and then pushing straight up to a production environment. What this is here is the Kubernetes source code. This is used by every major cloud as a service. It's used by every Fortune 500 company. It's a huge, huge service that gets shipped to hundreds of thousands of developers around the world every single release. And I think is a really good example of why you would want branch protection rules, why you want reviews, why you would want all different kinds of things protecting your Git repository. Because while Git is technically cryptographically sound, it is not that hard to break that. And that's what I want to show here. First, let's make sure that there's nothing on this branch. It's clean. It's the main head that I just pulled down. And what we want to go into is an interactive rebase. So we're going to do git rebase I for interactive. And let's do the last 100 commits or so. What this jumps us into is essentially the ref log for the Git repository, but it allows us to go down to some arbitrary commit deep within the ref log, and let's just take one and we're going to edit it. So now what I can do is save and exit, and what I am in now, if I do a git status, is an interactive rebase mode where Git recognizes that I'm interactively rebasing something on top of this commit, and that we should either make some edits, continue the rebase, or abort the rebase, which essentially is changing a bunch of those commits on top of the one that we are going to edit. And let's inject something slightly malicious. And let's go into something in the package, maybe in the API, maybe something in the node. You get the idea. What we want is just some code path that we can inject some malicious little piece of code. Maybe down here, just for demonstration's sake, all your levels belong to us. Save that, and now we have some little piece of malicious code that wasn't there before that we're going to commit deep into the ref log. Exit out of here. We're going to git add -p. Yes, we want that little piece of malicious code. Git commit, and importantly, we're going to amend. Now, when I amend this, this is the original commit message from the one that we are editing deep inside of the Git rebase. This is the original author from GitHub that we are going to sort of assume, and then we are going to save that, git rebase, continue It's doing the big rebase with all of those, including the commit that we just maliciously changed. Now, at this point, if I was Mr. Peter Levels, I would git push this directly into the main branch where GitHub would just pick that up, do a production release, and within seconds, it would be released out into the world. So fast, so easy. And we can do that with git push origin master. And GitHub is going to reject this for me. This is where my demonstration ends with Kubernetes, because permission to Kubernetes denied to my GitHub username. And that's because they have sane branch protection rules set up, and they require pull requests. Oftentimes, those pull requests require multiple reviews from owners, and it all gets excruciatingly inspected to make sure that something like this doesn't happen. And again, just for demonstration's sake, let's look back at the code, go back into that file that I edited, and way down here, my malicious little piece of code is still there at the top of the head on the Git repo. But if we git blame it, we'll see that right here, it looks like it was committed back in July 31st by not me, but somebody that I rebased on top of. Now, any astute Git scholar will know that by doing a deep Git rebase like that, I've essentially broken the Git ref log as it's known by the origin up on GitHub. If I look at the ref log here, git log, I can see that the top commit starts with 19.13.14. And if we pull over the Kubernetes commit log here on GitHub, you'll notice that this same commit, reduced length of no trees, starts with DC5E, which is definitely different than this one here. And that's because a rebase will actually change all of those SHAs cryptographically from the one that we edited all the way up the tree. So if other people were pulling this down, they would see that that had changed. They would need to do a big rebase of their own, or a reset from what would be up on origin. But in Peter's Levels cases, that'd already be pushed to production, that would already be pushed out to users, and really the damage would already be done. So if you're working on a service, a business, some piece of software, a library that users depend on, and you're pushing straight to production, please use branch protection rules so that in this age of security and crazy things happening out there, you don't get pwned and all of your users don't have some terrible thing happen to them. Thank you.